Hello and welcome to INE's CCI Service Provider version 5 lab course. Today we will look at iBGP. For some of you who do not know me, my name is Rohit Pardasani and I would be your instructor throughout this course. I have 5 CCIs: CCI in route switch, CCI in security, voice, collaboration and service provider. So let's kickstart this session by learning about iBGP. Now basically iBGP connection is basically a peering between two devices who are in the same autonomous system. iBGP has an administrative distance of 200. So if you receive a route from an iBGP neighbor and if you do a show IP route, you would see that the AD is set to 200. By default, iBGP peers are set with a TTL of 255, which basically means that neighbors do not need to be directly connected. If you remember, in eBGP, they had to be directly connected. And if they were not, we had to change the eBGP multi-hop value. However, in iBGP, they are by default set to 255, which means that I do not need to have two routers directly connected with each other to establish iBGP neighborship. They can be separate or they can be not directly connected as long as I have some kind of reachability between my two routers. Maybe there's an underlay iBGP running. As long as they have reachability, you can establish an iBGP neighborship. The next hop does not change when you advertise a route to an iBGP neighbor. So if I receive a route from an eBGP neighbor and I give my neighbor the route who is an iBGP neighbor, I would not change the next hop. I would keep the next hop unchanged. Routes received from an iBGP peer can only be advertised to an eBGP peer. You cannot give a route learned from an iBGP neighbor to another iBGP neighbor. This is BGP's split horizon rule. Local AS is not prepended when routes are advertised to an iBGP neighbor. Remember, local AS is only prepended when you give the routes to an eBGP neighbor, not to an iBGP neighbor. To an iBGP neighbor, the local AS does not get prepended. It remains unchanged. And then finally, we have the split horizon rule that I was talking about. The split horizon rule in iBGP states that if you learn a route from an iBGP neighbor, you cannot give to another iBGP neighbor. If you do want to give that to another iBGP neighbor, you would need to configure confederation or route reflectors, or maybe do a full mesh. iBGP requires full mesh or route reflectors to be configured because of the split horizon rule. So let's have a quick look at this iBGP example. Here I have some eBGP connections and I have some iBGP connections. So I have iBGP running all the way in AS200. It's not a full mesh configuration. R2 is forming iBGP with just R3 and R5. I have iBGP between 3 and 6, 6 and 7, 7 and 9, and I have eBGP between 3 and 4, 1 and 2, 10 and 9, and 7 and 8. So now what's going to happen when router 1 advertises a route to router 2? How are those routes going to be advertised across AS200 and how will those routes reach AS400 or AS800? So let's see that. Now since this is not a full mesh configuration, a lot of iBGP rules will apply, which we have to take care of. So if R1 advertises 1.1.1.1 to his neighbor router 2, because router 2 is an eBGP neighbor, router 1 is going to prepend his AS and he would put himself as the next hop. When R2 gets that route, he installs the route in his routing table. However, when he advertises that route to his iBGP neighbor, which is 3 and 5, when he advertises to them, he would not prepend the AS and he would not change the next hop. Now, would R3 and R5, when they receive the route, would they put that route in the routing table? No. The route would be in the BGP table. However, it would not go in the routing table. If you remember, for the route to go in the routing table, the next hop must be reachable. Is the next hop reachable for R3 and R5? The next hop is R1. Is that next hop reachable? No. So we have to make that reachable. How can I achieve that? Well, one way would be either I go and advertise this link here. I advertise this link in the IGP, which is running inside AS200. Either I advertise that, or I advertise this link in BGP, or I redistribute this link in IGP, or maybe I go to R2 and I configure next hop self. So if R2 changes the next hop to himself, in that case R3 and R5 would see R2 as the next hop, which is what we want. Because the link between 1 and 2 is not advertised in any routing protocol, so obviously it's not reachable, so R2 has to do a next hop self. So R2 will have to do a next hop self. Now once R2 sets the next hop self to himself, which has to be done manually, once he's done that, R3 and R5 would accept the route in the routing table, and now R3 would advertise that route to R4. When he gives the route to R4, he again prepends his own AS and sets the next hop to himself. Would he give the route to R6? No, R3 would not give the route to R6 because of split horizon rule. What does that rule say? Routes learned from an IBGP neighbor cannot be given to another IBGP neighbor. R3 has learned the route from R2, which is an IBGP neighbor, so he cannot give it down to R6. That's why we require a full mesh neighborship between 2 and 6, or I need to configure router 6 as a route reflector. So if I make R6 into a route reflector, in that case R6 would reflect the route down to his client, which is R6. Now when R6 gets the route, would he install the route in his routing table? Yes, because the next hop for him would not be R3, it would still be R2, because R2 had put himself as the next hop by giving the next hop self command. So R6 would see next hop as R2. Is R2 reachable? If there's no IGP running between 2 and 6, if there's no IGP running internally, then obviously the next hop would not be reachable. In that case, it would not install the route in the routing table. However, because internally I may be running some kind of IGP here, maybe I'm running OSPF, in that case for R6, the next hop R2 would be reachable through OSPF. So now when R6 gets the route, because the next hop is reachable, he installs the route in his routing table, and now he would advertise that route to R7. However, do you think he would give it by default to R7? No again. Because R6 has learned the route from an IBGP neighbor R3. Can he give the route to another IBGP neighbor? No. Again, the split horizon rule. So again, I would need to configure either a full mesh between 3 and 7, or I configure R3 as a route reflector. If I configure R3 as a route reflector, then R6 would reflect the route down to R7. And now R7 would install the route in his routing table if the next hop R2 is reachable. Now once R7 installs a route in his routing table, R7 would advertise this route to R8. When he gives the route to R8, he would put himself as the next hop and he would prepend his own AS. However, would he give the route to R9? No again, because again the split horizon rule applies, so I would need to configure R7 as a route reflector also. Only then he would give the route to R9. Would R9 give the route to R10 by default? Yes, because R9 has learned from an IBGP, but you can give it to an eBGP. This is an eBGP connection, so he would give it to R10. So basically, for the routes 1.1.1.1 to reach R8 and R10, R3 would have to be configured as a route reflector, and R6 would be the client of R3. Again, R6 would be the reflector, and R7 would be a client of R6, and R7 would be a reflector, and R9 would be a client of R7. Only then everybody would have the routes of 1.1.1.1. Now let's say if R10 advertises his loopback in BGP, let's say 10.10.10.10, and assumingly we had configured R3 as a reflector, R6 as a reflector, R7 as a reflector, as a route reflector. Now when R10 gives the route to R9, it's an eBGP connection, so AS path would be prepended and R10 would be the next hop. When R9 gets that, he puts the route in his routing table. when he gives the route to R7, the next hop would still remain the same, which is R10, and the AS path would still remain the same, which would be AS 1000. Now the problem is, when R7 gets it, R7 would not be able to reach the next hop. That's why R7 would not install the route in his routing table. That's why I would need to configure R9 with next hop self command on R9 towards R7. Similarly, on R2, I had to configure next hop self towards R3. Only then the routes of R1 and R10 would be reachable by everyone. Technically, if you have an eBGP neighbor and an iBGP neighbor, you should do a next hop self towards the iBGP neighbor. So if you look at this diagram, R2 has an eBGP and an iBGP, so I should do a next hop self on R2 towards R3 and towards R5. I should do a next hop self on R3 also, because even R3 has an eBGP neighbor and an iBGP neighbor, so he should do a next hop self towards R2 and towards R6. R6 does not need any next hop self because he does not have any eBGP neighbor. R5 does not need next hop self. Again, he does not have eBGP neighbor. R7 would require next hop self towards R6 because he has an eBGP neighbor, and towards R9. So basically R2, R3, R9 and R7, these routers would require next hop self towards the iBGP neighbor because they are the edge routers connecting to external ASs. So going back to this network 10.10.10.10, when R10 advertises to R9, R9 installs the route in his routing table, and then he advertises the route to R7. Now R7 installs the route in his routing table because now the next hop self has been fixed. So R7 sees R9 as the next hop. So he installs the route in his routing table. He advertises the route to R8, prepends the AS, sets himself as the next hop. However, would he give the route to R6? Now you would say no, because again split horizon rule, because R7 has received from 9, which is an iBGP neighbor, so he should not give it to 6. However, 7 will give it to 6. Why is that? Because 7 is a client of R6. 7 is not a reflector. 7 is just a reflector for 9. He is not a reflector for 6. 6 is the reflector for 7. So 7 is a client of 6. So why would R7 reflect it to 6? The reason is, the rule for route reflector says, if you have received the route from your client, so R7 has received the route from his client R9, if you receive the route from your client, you can give the route to anyone, to even your non-client, which is R6. So he gives the route to R6. Now R6 has learned the route from his client, he can again give it to R3. Now will R3 give it to 4? Yes, it's eBGP, no problem. Would he give it to 2? He is not a reflector, nor is 2 a reflector. There's nothing, no reflection configured between 2 and 3. So would 3 give it to 2? The answer is still yes, because R3 received the route from R6, and R6 is a client of R3. So if you receive it from a client, you can give it to everyone. So R3 gives it to R2. Will R2 give it to R1? Yes. Will R2 give it to R5? This answer would be no, because R2 has received from R3, who's not his client and who's an iBGP. So R2 cannot give it to R5. So here I would need a route reflector to be configured. Only then R5 would see 10.10.10.10. So let's quickly implement this, and we'll see all the problems that we have, and then we can also add next hop self commands to fix issues. We can also add route reflectors to fix issues of split horizon. Alright, so let's try and configure this. In fact, right now all my BGP configuration has already been done. So all the routers have been configured for BGP as per this diagram. For IGP within the autonomous system of AS200, I have configured OSPF. So entire AS200 is running OSPF internally. The WAN links are not running any kind of IGP. Router 7 is an iOS XR, it's iOS XR 1, and router 9 is iOS XR 2. So at this point of time, router 1 is advertising a route, which is his loopback. He is advertising that route to his neighbor, which is router 2. So as soon as router 1 advertises that route via BGP, he is going to prepend his AS and he would change the next hop to himself. The reason he does that, because he's giving the route to an eBGP neighbor, so he has to prepend his AS and he has to set the next hop to himself, which happens automatically. So if I look back at router 2, I can see that in show IP BGP, R2 has learned the route and the AS path contains AS 100 and the next hop is router 1. Now when R2 is going to advertise that route to his neighbor R3 and R5, at that time R2 would not prepend his AS because he's giving the update to an iBGP neighbor, so he would not prepend the AS. At the same time, he would not change the next hop. He keeps the next hop unchanged. Let's verify that on R3 and on R5. Show IP BGP. As you can see here that router 3 has the route in his BGP table. He has learned 1.1.1.1. He has learned that, but he is not installing that route in the routing table because this route is not accessible because the next hop is not accessible. Look at the next hop. The next hop is router 1's IP address, which is the WAN link. So for R3, that link is not reachable, so he cannot install that route in the routing table. So, and if you look at the AS path also, it only contains AS 100 because R1 had prepended AS 100. R2 did not prepend the AS, R2 did not change the next hop to himself. So R3 and R5, they both would have the route in the BGP table, but they would not install the route in the routing table. Because the route does not go in the routing table, R3 would not give it to anyone because you can advertise to your neighbor only if it's there in your routing table. Is it there in R3's routing table? Let's check that. Show IP route BGP. 1.1.1.1 is not in the routing table of R3, so he would not advertise to R4 or to R6. So the first thing that I have to do is fix the next hop issue. Now, how can I fix the next hop issue? How can I fix that? Well, next hop issues can be fixed in many ways. One way would be I advertise the WAN link in OSPF using the network statement. So I activate OSPF on my WAN link. The second way could be maybe I redistribute the WAN link in OSPF. The third way could be maybe I advertise the WAN link in BGP so that R3 and R5 would receive the next hop through BGP. So they would do a recursive lookup in BGP. The fourth way could be maybe I tell R2 to change the next hop to himself with the next hop self command. And the fifth way could be maybe I use a route map to change the next hop or set the next hop. So let's go to router 2 and set the next hop. So this time I would not do next hop self. I'll in fact show you that command, but I would not use that. I would use the route map to actually fix this. So if I want, I could go to router BGP 200, neighbor 3.3.3.3 and next hop self. I could do this, or I could do neighbor 5.5.5.5 route map to R5 outbound. So either way would work. So towards R3, I've done next hop self. So when R2 sends the update to R3, he would put himself as the next hop. And towards R5, I didn't do next hop self. Instead, I use a route map. So when I send an update to R5, I would check for the route map. Let's create the route map now. So route map to R5, permit sequence number 10, and says set IP next hop to 2.2.2.2, which is his own loopback. Let's exit out. And let's go back to 3 and check now. Show IP BGP. As you can see now, R3 has accepted the route. It has become valid and best. It must have gone in the routing table also because the next hop is 2.2.2.2, which is reachable through OSPF. So if I do a show IP route BGP, now R3 has the route in his routing table. Similarly on R5, if I do a show IP BGP, I should see the next hop as 2.2.2.2 because my route map is changing the next hop to R2's loopback. So different ways of actually configuring stuff. Now, would R3 give the route to R4? Yes, it's an eBGP neighborship, right? So R3 is going to prepend his own AS and he would set the next hop to himself and send the route to R4. So R4 should have the route in his BGP table. As you can see, AS part 200 was prepended and the next hop is R3. So, and if I look back at show IP route BGP, R4 has the route in his routing table also. So no problem there. But would R3 give the route to R6? R3 would not give the route to R6. Not because of anything else, but because of split horizon rule. R3 has learned the route from an iBGP neighbor R2, so he cannot give it to R6. So if I look back at R6 and do a show IP BGP, R6 does not even have 1.1.1.1 in his BGP table. He does not get that route because R3 would not advertise that route to R6 because routes learned from an iBGP neighbor cannot be given to another iBGP neighbor. Now how do I fix this? To fix this, I would need to configure R3 as a route reflector and R6 would be the client of R3. So let's go to R3 and say router BGP 200 neighbor 6.6.6.6 route reflector client. So now R3 is a reflector and R6 is a client of R3. So R3 is going to reflect the route that he's learned from R2 and he would send that route to R6. Now don't you think that route reflector breaks the rule of split horizon? The whole reason for split horizon to be there was to prevent loops. However, when R3 advertises the route to his neighbor, this specific route, when he advertises to his neighbor, he has received it from 2.2, right? So when he advertises to R6, show IP BGP 1.1.1.1, he adds a new community, which is originator and cluster list. Originator is the router ID of the device who got the route in the AS. Who got the route 1.1.1.1 into AS200? It was R2. So he puts originator as R2. And who was the reflector? R3. So he puts R3's router ID as the cluster list. If for some reason the route comes back to R3, R3 would discard the route because his own router ID is there in the cluster list. At the same time, if R2 receives the same route back, even R2 would discard the route so that there is no loop. That's why route reflectors, even though it breaks the rule of split horizon, it still gives you a loop prevention mechanism. Now R6 has the route in his routing table. Would R6 give that route to R7, the iOS XR? Again, no, because R6 has learned from an iBGP neighbor R3, so he cannot give it to another iBGP neighbor. So if I look back at XR1 and do a show BGP IPv4 unicast, you would see that he does not see 1.1.1.1. Again, because R6 is not giving that route to iOS XR. So I need to configure R6 as a reflector and our XR1 would be the client. So let's go back to router BGP 200, neighbor 19.19.19.19, route reflector client. Now when R6 reflects the route, he keeps the originator part same, but he adds himself in the cluster list. So now when XR1 gets the route, he should get the route 1.1.1.1. And if I do a show BGP IPv4 and look at that specific route, which is 1.1.1.1, if I look at that route, you would see that in the cluster list, I have R6 as well as R3. So originator is still R2. It's not R1 because R2 was the guy or the router who got the route in the AS200. So R2 is the originator and the cluster list will contain all the route reflectors. So R3 and R6. Now XR1 has the route in his routing table. Let's check his routing table. show IP route BGP. So he has the route in his routing table. Would he give it to a R8? Would XR1 give it to R8? Yes, because that's an eBGP connection. And when he gives that route to R8, he would prepend his own AS and he would put next hop to himself. So let's check show IP route BGP. R8 has the route. One thing that you must consider is XR1 will only advertise the route to an eBGP neighbor if an RPL policy exists. I have already configured an RPL. So for my eBGP towards 8, there's an RPL which says pass for inbound and outbound updates. I don't need an RPL for iBGP. But would XR1 give the update to XR2? No, because again the same split horizon rule applies. So if I look back at XR2, show BGP IPv4 unicast, XR2 does not have 1.1.1.1. So XR1 needs to be a reflector and XR2 would be the client. Let's go to XR1 and configure route reflector client. That's going to be inside neighbor 20202020, and here I would say route reflector. This should be under address family IPv4 unicast and route reflector client, and let's do a commit. So now if I look back at XR2, XR2 should have the route in his routing table. He should learn 1.1.1.1, which he has. And again, when XR2 gives the route to R10, he would prepend his own AS and he would set himself as the next hop, as long as you have an RPL on R9 or XR2 which says pass. Now again, let's look at the reverse way. R10 is advertising his loopback in BGP. Would that be given to R9? Yes. Would R9 accept it? Yes, if he has an RPL that permits inbound traffic or inbound updates. Would R9 give it to R7? Yes, but would he set the next hop to himself? No. So I need R9 to set the next hop to himself. Otherwise, XR1 would not see, would see the route in his BGP table, but would not install the route in the routing table. So if I look back here, 8.8.8.8, I see that 20.8.19.8 is my next hop. And in fact, the route is in my routing table. It's already there in my routing table, so I don't need the next hop. Maybe that maybe this network is there in IGP. Let's check. Show IP route. So 20.8. I think it was 20. In fact, it's not there. We were looking at the wrong route. 10.10.10.10 is in my BGP table, but it's not best, which means it's not gone in the routing table because this next hop is not reachable. Because the next hop is not reachable, obviously our XR1 would not install the route in his routing table and he would not advertise to anyone. So let's go back to XR2 and set the next hop to himself. Again, I could use an RPL, which could put a condition saying, okay, set the next hop to himself, or I could directly do next hop self. Let's go to router BGP 200 and do neighbor 19, and let's do a next hop. That should again be inside address family IPv4 unicast. Let's do a next hop self. And let's do a commit. So now when XR2 does a next hop self towards XR1, XR1 should see the route in his BGP table and he should make that as valid and best, because now the next hop is 20.20.20.20 and that network is reachable through OSPF. Would he now give it to R8? Yes, because that's eBGP, no problem there. But would he give it to R6? Now, XR1 is not a route reflector for R6. He's a reflector for XR2, right? So would he reflect it to R6? Let's go to R6 and check that. Show IP BGP, As you can see, R6 received the route automatically. I didn't have to configure R6 as a client of XR1. I didn't have to make XR1 as a route reflector, because if you receive a route from a client, XR2 is a client of XR1. So XR1 is a route reflector for XR2. So if he receives a route from his client, he can give it to whoever he wants. So he gives it to R6. R6 was a reflector for XR1, right? So R6 has also received from his client. He can give it to R3. So if I look back at R3, show IP, BGP, R3 also has 10.10.10.10. Would R3 give it to R2? Now there's no route reflectors configured anywhere else. The only places I have configured route reflector is here. I have configured here, and I have configured here. When R3 gets the route, he gets it from R6, and R6 is the client of R3. So again, he can give it to everyone. He can give it to R4, he could give it to R2. So if I look back at R2 now, R2 should also have that route in his BGP table, show IP BGP. He also has 10.10.10.10. Would R2 give it to R5? No. Would R2 give it to R1? Yes. If I look back at R1, show IP BGP, R1 has 10.10.10.10, but if I look back at R5, show IP BGP, R5 does not have 10.10 because R2 has learned from an iBGP who is not his client. In that case, he can only give it to eBGP, but he cannot give it to an iBGP neighbor. So R2 needs to be configured as a route reflector. Otherwise, R5 would never see R10's loopback. So let's go to router 2 and configure reflector. So what I could do is I could configure this under my BGP. So let's go to router BGP 200 and say neighbor 5.5.5.5 and then say route reflector client. So now 5 is a client of 2. So now 5 is a client of 2. So if I look back at 5 and do a show IP BGP, now 5 has 10.10.10.10. So you see, for iBGP, there are lots of things that you have to consider. You have to take care of next hop. You have to take care of route reflectors if you don't have full mesh. So you have to always be aware where you need next hop, where I have to fix the route reflectors or configure route reflectors. In the lab exam, they would not tell you in the question whether you have to configure route reflectors or you have to configure next hop self. You must be aware, you must always draw a diagram and look at the diagram and think, where do I need next hop self, where do I need route reflectors?